Good morning. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and in this segment, I'm going to stay with math. Now, why am I doing math? Because math is very important, especially when you go into sciences like physics and chemistry and biology and engineering, even nursing, accounting. You cannot escape math. Why? Because numbers don't lie. So today, I'm going to talk about general mathematics. So, the title of today's topic is, what is general mathematics? So I'm going to start off with the definition. Now, mathematics is the study of numbers, shapes, and patterns, and the word comes from the Greek word mathema, meaning science, knowledge, or learning, and it is sometimes shortened to maths in England, Australia, Ireland, and New Zealand, or math in the United States and Canada. The short words are often used for arithmetic, geometry, or simple algebra by students in their schools. So when it comes to mathematics, it includes numbers, how things can be counted, structure, how things are organized. Now, the subfield is usually called algebra. There's the place where things are in their arrangement. This subfield is usually called geometry. Change, how things become different. This subfield is usually called analysis. Then there's multiplication and decimals. Now, mathematics is useful for solving problems that occur in the real world. So many people, besides mathematicians, study and use mathematics today. Some mathematics is needed in many jobs. Example, people working in business, science, engineering, and construction need some knowledge of mathematics. Now, when it comes to problem solving, well, mathematics solves problems by utilizing logic. One of the main tools of logic used by mathematicians is known as deduction. Deduction is a special way of thinking to discover and prove new truths by utilizing old truths. To a mathematician, the reason something is true, which we know as a proof, is just as important as the fact that it is true, and this reason is often found by using deduction. Now, using deduction is what makes mathematics thinking different from other kinds of scientific thinking, which might rely on experiments or in interviews. Now, logic and reasoning are used by mathematicians to create general rules, which are a very important part of mathematics. Now, these rules leave out information that is not important so that a single rule can cover many situations. However, by finding general rules, mathematics solves many problems at the same time, as these rules can be used on other problems. These rules can be called theorems, or if they have been proved, or conjectures, if it is not known if they are true yet. Now, most mathematicians use non-logical and creative reasoning in order to find a logical proof. Sometimes mathematics finds and studies rules of ideas that we don't understand yet. Often in mathematics, ideas and rules are chosen because they are considered simple or neat. On the other hand, sometimes these ideas and rules are found in the real world after they have been studied in mathematics. And this has happened many times in the past. In general, studying the rules and ideas of mathematics can help us understand the world much better. Now, some examples of math problems are addition, subtraction, multiplication, division, calculus, fractions, and decimals. When it comes to algebra problems are solved by evaluating certain variables. Now, a calculator answers every math problem and the four basic arithmetic operations. Now, areas of study in mathematics. We deal with the number. Mathematics includes the study of numbers and quantities. It is a branch of science that deals with logic of shape, quantity, and arrangement. Now, most of the areas that are listed in textbooks or in a definition are studied in many different fields of mathematics, including set theory and mathematical logic. Now, the study of number theory usually focuses more on the structure and behavior of the integers rather than the actual foundations of numbers themselves. And so, what you have to do when it comes to numbers, you basically have to be able to solve the operation to get the number. Now, some of the numbers, again, can be fractions, decimals. Some of them can be variables where you have to find what the variable is. Now, when it comes to structure, many areas in mathematics study the structure that an object has. Most of these areas are part of the study of algebra, because in algebra you have number theory, abstract algebra, linear algebra, order theory, graph theory. Now you also have shape. Some areas of mathematics study the shapes of things. Many of these areas are part of the study of geometry, where you have topology, geometry, trigonometry, differential geometry, and fractal geometry. Then there's change. Some of the areas study the way things change. Most of these areas are part of the study of analysis. And this is where you get into calculus, vector analysis, or we just say analysis, vector calculus, differential equations, chaos theory, dynamical systems. Now, applied mathematics uses mathematics to solve problems of other areas such as engineering, physics, and computing. Numerical analysis, optimization, probability theory, statistics, mathematical finance, game theory, mathematical physics, fluid dynamics, computational algorithms are all part of applied mathematics. Then you have famous theorems. And these theorems have interested mathematicians and people who are not mathematicians. For example, you have Pythagorean's theorem. You have Fermat's last theorem, Goldbach's conjecture, twin prime conjecture, Gödel's incompleteness theorems, Poincaré conjecture, Cantor's diagonal argument, four-color theorem, Zorn's lemma, Euler's identity, Church-Turing thesis. Now, these are theorems and conjectures that have greatly changed mathematics. Then you have the Riemann hypothesis, the continuum hypothesis, P versus NP, again, Pythagorean theorem. And if you were into statistics, you have what we call CLM, central limit theorem, fundamental theorem of calculus, fundamental theorem of algebra, fundamental theorem of arithmetic, fundamental theorem of projective geometry, classification theorems of surfaces, the Gauss-Bonnet theorem, Fermat's last theorem, and Kontravoit theorem. Now, foundations and methods. Now, progress in understanding the nature of mathematics also influences the way mathematicians study their subject. Now, you have the philosophy of mathematics, you have mathematical institutionalism, mathematical constructivism, foundations of mathematics, set theory, symbolic logic, model theory, category theory, logic, reverse mathematics, and you have a table of mathematical symbols. Now, when it comes to the history and world of mathematics, the history of mathematics, timeline of mathematics, mathematicians, Fields Medal, Abel Prize, Millennium Prize problems, Clay Math Prize, International Mathematical Union, mathematics competitions, lateral thinking, of course, mathematics and gender. Now, when it comes to awards in mathematics, there is no Nobel Prize in mathematics. Why? Because mathematicians can receive the Abel Prize and the Fields Medal for important works. Now, the Clay Mathematics Institute has said it will give $1 million to anyone who solves one of the Millennium Prize problems. Now, again, when we talk about mathematics, there are tools involved with mathematics, and some of them are old and some of them are new. Now, the older tools, and one comes from China, you have the abacus. Then you have Napier's bones, the slide rule, mental calculation, and you have the ruler and compass. And then we move up to the newer tools like calculators and computers, programming languages, computer algebra systems, internet shorthand notation, statistics software, for example, SPSS, SAS, programming language, and of course R, which is also a programming language. So overall, when we deal with mathematics, basically, mathematics is the study of numbers, shapes, and patterns. And what's included in mathematics? Numbers, because you need to know how things can be counted, structure, how things are organized, place, where things are, and their arrangement, and of course, change, how things become different. And you have subfields of mathematics like algebra, geometry, and analysis, and you also have operations and numerical systems, like you have decimals, and you have multiplication, which is an example of a mathematical operation. And that concludes this topic on general mathematics. If you like what I just presented, please like, share, and subscribe. Also, if you are looking for some political content or relationship content, check out the 401 Talk Zone radio show on YouTube. And if you want more in-depth topics that are too hot for YouTube or too lengthy for YouTube, if it's a STEM topic, check out the 401 Talk Zone radio show on Blog Talk Radio. 215-383-5785 is the number. And I'd like to thank you once again for viewing this video on general mathematics from the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. Please have a wonderful day.